In this video, we're going to look at non-inverting amplifier. We are going to be explaining it using a past exam problem. Right, please remember to subscribe to the Physics Tips for Cambridge Students YouTube channel, and remember to like, share, and comment. Right, so without much further ado, let's get started. Right, the problem reads, the circuit shows a non-inverting amplifier with an output voltage of 8.0 volts. So the diagram there shows the amplifier. Now the two resistors, the potential divider, as you can see, it feeds into the inverting input, which makes it negative feedback because it's coming from the output. So that is negative feedback. Now V in is going to the non-inverting terminal. That's what makes it a non-inverting amplifier. Right, so let's go to the question. The question says, state two differences between an operational amplifier used as an inverting amplifier and as a non-inverting amplifier. In the inverting amplifier, like I said, that V in goes into the inverting terminal. In the non-inverting amplifier, V in must go to the non-inverting input or terminal. Also, with an inverting amplifier, the output is half a cycle out of phase. In other words, it is 100 degrees out of phase with the input. Whereas in a non-inverting amplifier, the input and the output are exactly in phase. The input impedance is higher for an operational amplifier used as a non-inverting amplifier as well. Also, you can distinguish them in terms of the gain. Now, the gain in an inverting amplifier is given by minus RF over Rin, where RF is the resistance in the feedback resistor and Rin is the resistance in the input. Whereas in the non-inverting amplifier, the gain is equal to 1 plus RF over Rin. Remember, RF is the feedback resistor and Rin is the input resistance. Right, so let's move on to the next part. Says that calculate the gain of the amplifier shown in the circuit. That's where we're saying that this is a non-inverting amplifier, so the expression for the gain would be 1 plus R1 over R2, or you could say 1 over RF over Rin. So in this case, it is 1 plus 40 over 20, and that should give you a gain of 3. Then going to the next one, part C says, calculate the value of the input voltage V in. Remember, the operational amplifier has got a very high gain. We do not want it to saturate. So the inputs, the two inputs, the V in and the V in that is on the V plus there, and the V minus there, which is the inverting terminal, must be approximately equal for it not to saturate. So which means the voltage that goes to the non-inverting terminal and the voltage that goes into the inverting terminal must be the same so that it does not saturate. So using our potential divider, the 20 kilo ohm goes on the numerator, 20 over 20 plus 40 times 8 volts. That will be the voltage that's fed back to the inverting terminal. So that voltage should equal the voltage in so that our amplifier does not saturate. So with that in mind, we're saying that the input voltage is supposed to be 2.67 volts. Okay. Alternatively, you could use the fact that we now know the gain. The gain is 3, so V out is 8. So getting V in would be 8 over 3, which is 2.67. Still the same. Get either method would work. Then part D, calculate the value of the current in the 40 kilo ohm resistor. Current in the 40 kilo ohm resistor. Right. So current is equal to PD over resistance. Now the PD is 8 volts, that's the output PD. And then the resistance will be the two resistors in series, which is 20 plus 40 times 10 to the power of 3, because they are kilo. So that gives you about 1.33 times 10 to the power of minus 4 amps. Now the last part, E, says determine the voltage across the 20 kilo ohm resistor. So that is the same. You just say 20 over 20 plus 40 times 8 volts, which should give you 2.7 volts. Okay. So this voltage is the same as that of part C, which is the 2.0, which is the input voltage. Yes. Remember, our operational amplifier must not saturate, so it should be the same. Okay, so the voltage across the 20 kilo ohm resistor is the 2.7 volts. Remember, we had two ways of doing part C. So, well, the second part, the first way that I gave you answers this problem. Okay. Right, so this is the end of the question. Please consider subscribing to the channel and like, share, and comment. Signing out.